A special delivery was made to the United States Navy. This present stands unparalleled in the ever-evolving landscape of maritime warfare. As the first of its kind, the United States Navy's Orca extra-large unmanned undersea vehicle stands at the forefront, poised to revolutionize the very fabric of maritime superiority. What impact will the Orca extra-large unmanned undersea vehicle have on the balance of power in naval operations on a global scale? Join us as we delve into the world's largest unmanned submarine delivered to the U.S. Navy. Set sail into the future. Over the years, the United States Navy has proven to be an unstoppable force in the maritime world, so it comes as no surprise when the Orca extra-large unmanned undersea vehicle was delivered to their doorsteps. Over the past 20 years, naval drones have become indispensable elements in contemporary maritime activities, transforming the capabilities and tactics of naval forces globally. Within the United States Navy, multiple state-of-the-art unmanned underwater vehicles are currently undergoing various production phases aimed at enhancing the branch's capabilities beneath the sea. Included in these innovations is the Snakehead, distinguished as the largest submarine-launched unmanned underwater vehicle, the Razorback, a medium-sized vehicle designed for torpedo launch and recovery missions, necessitating a dry deck shelter and diver intervention for retrieval, and the Viperfish, a naval drone possessing comparable capabilities. However, the most pivotal and revolutionary drone model in the United States Navy is the extra-large unmanned undersea vehicle, recognized as the world's inaugural extra-large unmanned underwater vehicle. The inception of Boeing's Orca initiative dates back to 2012, marked by the commencement of the design and development of the Echo Voyager, an extra-large unmanned undersea vehicle serving as a proof of concept. Successfully tested at sea in 2017, the Echo Voyager stands as the sole vehicle worldwide of its size and capabilities. Demonstrating unparalleled autonomy, it has logged over 10,000 operating hours autonomously at sea, covering hundreds of nautical miles. Notably, this vehicle laid the groundwork for the United States Navy's Orca extra-large unmanned undersea vehicle competition. Boeing's Orca, an autonomous underwater vehicle crafted for the United States Navy, traces its origins to September 2017. During this time, the Navy awarded contracts valued at around $40 million each to Boeing. Earlier in the same year, Boeing had established a partnership with HII to construct unmanned submarines. Additionally, Lockheed Martin joined forces with Boeing in developing competing designs. The objective was to create an extra-large unmanned undersea vehicle with the capability of autonomous operations lasting up to several months on various missions. In February 2019, the Navy granted a $43 million contract to the Boeing HII consortium to initiate the construction of 4 extra-large unmanned undersea vehicles. These vehicles were to be modeled on Boeing's previous autonomous underwater vehicle, Echo Voyager, a prototype that Boeing had independently funded and designed exclusively for testing purposes. In the subsequent month, the Navy included a 5th vehicle in the order, bringing the total contract value to $274.4 million. The scheduled completion for the deliveries of the Orca vehicles was set for the conclusion of 2022. In December 2023, the Navy received the first Orca after successfully conducting acceptance tests, which encompassed thorough surface and underwater trials as confirmed by Boeing. The United States Navy intends to deploy the extra-large unmanned undersea vehicle for various potential capabilities, including mine countermeasures, anti-surface warfare, anti-submarine warfare, electronic warfare, and strike missions. Ann Stevens, Boeing Maritime and Intelligence Systems Vice President, describes it as the culmination of more than a decade of pioneering work, developing a long-range, fully autonomous undersea vehicle. She goes further to say it has been a pleasure of witnessing the team bring the first-of-its-kind capability to life. She is also proud of their innovation, perseverance, and unwavering commitment, which has yielded the most advanced and capable UUV in the world. With the Navy's partnership, she and the team look forward to continuing to deliver this game-changing vehicle to the fleet. The Echo Voyager. Boeing's successful design for the Orca program is derived from its Echo Voyager, a fully autonomous, extra-large unmanned undersea vehicle unveiled in March of 2016. The company underwent testing of various Echo Voyager configurations, enhancing the platform's performance. The initial sea trial occurred in 2017, followed by a second test in 2019. With an overall length of 26 meters, accounting for the added payload carriage, a width of 2.6 meters, and an air weight of 50 tons, Echo Voyager is equipped with a hybrid rechargeable power system and a modular payload bay. This submersible is capable of conducting operations for extended periods, and its launch and recovery do not necessitate support ships. Orca is set to showcase a modular design characterized by an open architecture, offering flexibility for potential reconfiguration. The system will encompass guidance and control, autonomy, navigation, and maneuvering capabilities. The extra-large unmanned undersea vehicle will be designed with integrated interfaces to facilitate future upgrades, adapting to the latest technology and addressing evolving threats. Its operational capabilities include traveling to a designated area, remaining there, establishing communication, deploying payloads, and safely returning to its home base. An active buoyancy control system on board will primarily deliver functionalities such as autonomous buoyancy control, seafloor mooring, and forward and aft trim control. The Orca Extra-Large Unmanned Undersea Vehicle. Unique in its category, Boeing's Orca Extra-Large Unmanned Undersea Vehicle stands out as an independent and distinct creation. With an impressive length of 85 feet and a payload capability of 8 tons, this diesel-electric submarine is designed for optimal versatility and endurance in naval operations, offering the capability for both autonomous navigation and remote control, catering to a diverse range of missions. Featuring a modular payload bay with an 8-ton dry weight capacity, powered by an 18 kW battery, and equipped to accommodate external payloads, the Orca has interfaces supporting current and future payload requirements. This underwater vehicle is capable of carrying sonar payloads, including the Raytheon ProSAS PS60-6000 synthetic aperture sonar, which enhances ocean floor mapping capabilities. The Orca Extra-Large Unmanned Undersea Vehicle boasts a cruising speed ranging from a minimum of 2.5 knots to a maximum of 8 knots, with the optimal operational speed falling between 2.5 knots and 3 knots. Its operational range extends to nearly 6,500 nautical miles. A notable feature of Boeing's design is the hybrid propulsion system. This configuration allows the Orca to operate silently beneath the waves for extended periods, utilizing battery power that is subsequently recharged by surfacing and using the diesel engine, facilitated by a retractable mast functioning as a snorkel. The payload section can accommodate modules up to 34 feet in length, and the craft's maximum speed is 9 miles per hour. It possesses a range of 6,500 miles and an endurance spanning an unspecified number of months. Autonomous systems handle navigations and execute missions even in contested waters. The Extra-Large Unmanned Undersea Vehicle incorporates advanced navigation systems featuring cutting-edge technology, ensuring precise navigation and obstacle avoidance, enabling effective operation in diverse underwater environments. Despite its size compared to conventional manned submarines, this deceptive appearance results from its lack of life support systems. As a result, the Orca is a highly efficient and compact vehicle capable of accommodating a wide range of functionalities in a limited space. Due to its size, the specific deployment methods for such a large drone within the Navy are currently uncertain, but potential approaches include utilization from large surface ships and piers. The Navy's existing expeditionary sea bases could present a suitable option. From the shallow zones along coastlines to the deep expanses of the open ocean, the Orca demonstrates confident and precise maneuverability. Its discrete acoustic signature enhances its stealth capabilities, allowing it to operate covertly and seamlessly blend in with the surrounding seascape, ensuring the vehicle can execute missions without alerting potential adversaries to its presence. The Orca's initial focus, established during early development, in a blog post for the United States Naval Institute, retired Commander Brian Dulles suggests combining the range, autonomy, and flexibility of unmanned underwater vehicles like the Orca with the warhead capabilities of a mine. Compared to crewed submarines that can carry submarine-launched mobile mines, the Orca poses an even greater challenge for adversaries to detect. Currently, the Orca is well suited to carry 2 of the Navy's latest sea mines: the Hammerhead, a seabed-dwelling torpedo that listens for enemy submarines to strike, and the Clandestine Delivered Mine, a cylindrical underwater mine with undisclosed capabilities. Exceeding expectations. Like any advanced piece of military technology, the Orca's potential extends well beyond its initial mission set, and its conceivable roles have expanded, igniting the interest of military strategists and sparking speculation about its future capabilities. Intelligence gathering stands out as another potential function. Leveraging its stealthy design, extended range, and cutting-edge sensors, the Orca can infiltrate enemy territory, collecting crucial information about naval assets and movements. The versatile design of the Extra-Large Unmanned Undersea Vehicle also positions it for anti-submarine warfare. Equipped with advanced sensors and weaponry, the Orca can effectively track down and neutralize enemy submarines, functioning as a potent undersea hunter-killer. Its modular construction allows for the carriage of a diverse array of sensors, weapons, and equipment, transforming it into a genuinely multi-mission platform. Additionally, the Orca's payload bay permits the integration of vertical launch systems, enabling it to unleash cruise missiles against enemy ships, coastal installations, and even inland targets. The development journey of the Orca extra-large unmanned underwater vehicle faced challenges and setbacks. A report from the Government Accountability Office in 2022 revealed that, as the prototypes were set to roll out, the unmanned mine-laying submarine program was 3 years behind schedule and $242 million over budget. The COVID-19 pandemic significantly contributed to these setbacks, causing production issues such as a shortage of batteries, qualified welders, and titanium. Nevertheless, the United States Navy remains committed to the program, with officials adjusting the tentative delivery window to between February and June 2024 for all 5 vehicles. In early 2023, the Navy announced preparations to transform the Orca from land-based testing to underwater trials within the next year. The emergence of the Orca has sparked a global race in the development of extra-large unmanned underwater vehicles. While the United States leads the charge, other nations like Britain, Japan, China, Russia, and South Korea are swiftly entering the field, eager to secure their positions at the forefront of maritime technology. As these nations advance, the fate of Boeing's Orca extra-large unmanned undersea vehicles as the world's first vehicle of its kind remains uncertain. Thanks for watching. While you're still here, click on the link appearing on your screen to watch another of our interesting videos. See you there.